Hi, I'm Lee from St. Louis, Missouri. It's Tuesday, August 21st around 10 p.m. and I want to show you a project that I've been working on for the last 2 years. It's called TRILLSAT, and as you can see, it's a tethered robotic craft, but it also acts as a radio platform, and it is self-powered, solar powered. It is also self-propelled using a capstan drive to move up and down paracord. And the paracord actually takes on a catenary shape, and it uses the catenary for accurate seasonal solar alignment, but it also uses this planetary mass to tilt the craft for sunrise, sunset, daily solar alignment. And it's weatherproof. It's made out of PETG plastic. It's got an acrylic cover on it. The fasteners are stainless steel. It also has some brass fasteners, and there's channels for airflow. And it's made for rain, snow, sun. It can actually... There's a cooling fan inside that is also an inertial gyroscope for stabilization, because when the craft starts to wobble, it loses solar alignment. But when the gyroscope is turned on, it should start to stabilize and not twist sideways to keep the solar alignment. And right now it's on what's called the test frame. I'm going to come around. Oh, before I do that, I'm going to show you one last thing. There's there are several communication systems in the craft, but there's one final communication system I added, and it's called Thump, and tethered haptics using Morse pulses. And what it allows you to do is to vibrate the tether at the end, and there's an inverted Morse sequence that is received by the accelerometer in the center, and then what it does is it vibrates this mass, which acts as an eccentric mass, to send the Morse code back to the person. It's a haptic communication system. Anyway, come around here. Let me show you the underside. This is the radio box. This is the gondola unit. This is the power regulation box. The radio box has the CPUs in the radio system. This is a ham radio. Underneath that ham radio is a radio interface. There's a Raspberry Pi Zero W. There's an ESP8266 with Wi-Fi. Circuit board A is here. There's a spotlight made out of a dollar store flashlight, and there's a void here for an optional camera, but I don't use that. And then there's the LCD display of the radio, which I can change. Inside here's the gyro fan. This is called the battery frame. Provides structural support to the craft. There are 6 lithium-ion 18650B cells that can be bank switched. That's how I control the power. And the gyro fan's powered by a BLDC motor. It comes from a DVD drive. It's under PWM control. Then there's a second motor here. It's a screwdriver, and it's a cordless screwdriver. And I cut off the end of it, and I removed the battery, put in an H-bridge, and that's also under PWM control. This capstan unit here, or the capstan, there's a careful guides and pulleys in place to allow the tether to go around the capstan, and that provides a lot of different functions. The power regulation box here has a lot of different things in it. It's got circuit board B, it has the solar panel USB regulator, it has a battery bank USB regulator. On top of that is a microcontroller, and on top of that is a QI wireless charger, which I use as what's called the QI dock. Also, I forgot to mention, underneath the gyro fan is another microcontroller that controls the motor functions, and that's circuit board C. And then there are also these CDS LDR photo detectors for detecting solar intensity, and they're at 45-degree angles. So I'm going to go around to the back side. I'm going to show you this thing. This wooden frame is called the test frame, and it folds, and it folds for easy transportation. And so in order to stabilize the tether, I used a counter tether, which is a wire rope or steel cable. And there's a turnbuckle that allows me to adjust the tension of this tether. There's also a clevis that allows me to easily remove it. And this whole frame is weighted down with what I call the arc, and the arc is the storage case for the craft itself. But in this arrangement, the arc acts like a machine. It bolts to the frame, it lifts the frame up, and it keeps the frame from tilting sideways, because when this mass comes around, the thing could wobble and fall. So that prevents that from occurring. It also operates in a few different modes. When the craft is inside the ark, it keeps it stabilized so it doesn't move around inside. And then these braces down at the bottom can act as posts when bolted onto the side, and then it goes into a different mode where instead of having the tether for locomotion, it can still change the angle just for demonstration purposes. Anyway, that's about it for now. I'm going to show the different subsystems in future videos. Thanks.